Welcome to The Explainer. We're diving right into something absolutely fascinating today, the hidden plots, the invisible scripts that literally govern our daily lives. We interact with technology all day, every day, but how often do we actually stop to think about the master plans running the show right behind our screens? Well, today, we're pulling back the curtain. We're going to look at the architect's blueprint of the digital world, the algorithm. Okay, let's dive right into this. Have you ever wondered why Google Maps just kind of magically knows the absolute fastest route to get you out of a traffic jam? Or think about TikTok. How does it know exactly what video is going to make you laugh, serving it up right at the perfect moment? Well, the secret isn't magic. It's actually an invisible, meticulously written script. See, before a single line of computer code is ever typed out, programmers have to author a story. They have to map out a clear, step-by-step solution to a problem. So let's get into Section 1, the invisible magic around us. We're going to demystify the core of problem solving. Like I said, before any actual coding happens, a narrative really has to be established to bring order to the chaos. At its absolute core, an algorithm is just a logical sequence of steps. It transforms an input into a desired output. Think of it like a recipe, right? A chef wouldn't just throw a bunch of raw ingredients into a pan without a plan, and a programmer doesn't just throw code at a computer. An algorithm is that step-by-step procedure, the master plan, the overarching story arc that gets mapped out way before the heavy lifting of construction even begins. And the beauty of it is that it focuses entirely on how to solve the problem, completely independent of whatever programming language might be used later on. Moving on to Section 2, Everyday Stories We Tell. And as you'll see, you are actually already an algorithmic thinker. Let's narrate a little micro-story together. The highly suspenseful daily ritual of making your morning coffee. So, Step 1, get a cup. Step 2, add coffee and sugar. Step 3, boil water. Step 4, pour the water. Step 5, stir. And Step 6, drink. Now think about what happens to our little story if we say skip Step 3 and forget to boil the water. The whole narrative literally falls apart. You'd just be chewing on dry, bitter coffee grounds, yuck. The point is, every single step in this sequence matters, and they absolutely must happen in a specific order. And that, my friends, is an algorithm. And this perfectly illustrates how the exact same concept applies to something a bit more complex, like an ATM withdrawal. It's just another everyday algorithm in action. You've got your inputs, right? Inserting the card, entering your PIN, and requesting a specific amount. Then the process happens. The machine verifies the PIN, checks your account, makes sure you have the balance, deducts the money, and records the transaction. Finally, the output. It dispenses your cash. Input, logical process, output. It's a perfect little story with a very happy ending for your wallet. Which brings us to Section 3, Blueprint versus the construction. Let's look at why the story must precede the build. Just imagine the absolute disaster of trying to build a house without an architect's blueprint. I mean, you'd waste materials, you'd make structural mistakes, and you honestly wouldn't even know where the walls are supposed to go. Programming is exactly the same way. The algorithm is that blueprint. It's the plan, it's language independent and written in a way that is super easy for humans to understand. Programming, on the other hand, is the construction phase. That's where you use specific coding languages and it's written specifically for a computer to execute. If you skip the algorithm phase and just dive right into building, your code is going to get incredibly confusing, bugs will multiply, development grinds to a halt, and trying to fix things later on, absolute nightmare. So the architect's grand plan really must always come before the builder starts laying the bricks. Okay, Section 4, Traits of Great Algorithms. Here we'll cover the rules of a functional and reliable story. So there are some very distinct rules to authoring a functional algorithmic story. First off, it's got to be clear. Every single step must be easy to understand. Second, it must be ordered in the correct sequence, just like our coffee example, right? Third, it has to be finite. Basically, it must eventually finish. An algorithm that runs forever in an infinite loop is a digital tragedy. We definitely don't want that. Fourth, it should be efficient. You want to use the fewest steps possible to save time and computing resources. And finally, it must be correct. It needs to always produce the expected result when you give it a valid input. Let's move into Section 5, Authoring Your First Blueprint. We are going to turn real-world problems into logical steps. Whenever programmers start authoring these scripts, they always begin by identifying exactly what they're working with and exactly where they want to end up. They're establishing the beginning and the end of the narrative. For instance, if we have a username and password as our input, our desired ending, or the output, is a login confirmation.
If we input search terms, our story ends with search results. If we input prices and items at a grocery register, the output is a receipt. Establishing the beginning and the end makes charting the journey in between much, much easier.
Let's actually walk through the mini narrative of a standard social media login together. Step 1. The user enters their username and password. Step 2. The system checks if that username even exists in the first place. If it doesn't, well, the story ends right there with a user not found message. But if it does exist, we move on to step 3, which is verifying the password. Is it correct? If yes, boom, login successful. If no, it displays incorrect password. Now, notice something really important here. We didn't use a single line of Python or Java or C++, not one. Yet literally any programmer in the world could look at this plot and perfectly understand how to build it.
To write these plots out, programmers often use something called pseudocode. And pseudocode is simply a simplified way of writing programming logic using plain old English. It essentially acts as the actual script for our story before it ever gets translated into computer code. Taking a look at this example, we start. We input an age. If the age is greater than or equal to 18, we display adult. Otherwise, we display minor. And then we end. It's just incredibly clean, it's highly logical, and it's super easy for any human to read.
Now, another amazing tool these tech authors use are flowcharts. If pseudocode is the script, you can think of flowcharts as the visual storyboards. They use specific symbols to map out the logic. So an oval represents the start or end of the process. A rectangle shows a specific action or process that's happening. A diamond represents a decision point, a dramatic fork in the road that requires a yes or no answer. And finally, arrows show you the exact direction the story flows. They are just a fantastic way to visualize the entire program logic at a glance before any actual coding begins. I want to leave you with this climactic reality check, a quote that I think perfectly summarizes our journey today. Programming languages are tools. Algorithms teach you how to think. I love that. Learning Python or Java doesn't automatically teach you how to solve problems, just like buying a really nice hammer doesn't automatically teach you how to build a house. Logic, structure, and algorithmic thinking, that is what truly makes a great programmer. Once you master this mindset, learning the actual coding language becomes significantly easier. So, as we wrap up this explainer, I want to leave you with a bit of a provocative question. If code is simply the translation of a story, what exactly makes someone a truly logical thinker? How do we go about sharpening that underlying logic? Well, that is exactly the cliffhanger we're going to explore in the next phase of our journey. Thank you so much for joining me to uncover the algorithms around us. Keep thinking logically, keep authoring great solutions, and I will see you in the next explainer.